In this lesson, we're going to talk about similar triangles using angle, angle. So as long as we have two angles that are congruent, that correspond to each other, then the triangles are similar. So we're going to look down here, and I can go ahead and figure out what angle A is because I only see one right now, B and D, that are congruent. So I need to double check and make sure that A is either 80 or F is either 58, which we could kind of do both if we needed to. And so I'm going to subtract the two that I know from 180. And there we go. That one's 80. So you could stop there, or if you again wanted to try this one, you could subtract those two and confirm that F is 58. So we do have congruent triangles, so we're going to label A again matches up with E, B matches up with D, and C matches up with F. And then by angle, angle, similarity. So on this next one, we have parallel lines, which means alternate interior are congruent. So let's go ahead and mark those. So we have this pair here. Could also mark the Q and the N, or by vertical, we could mark these. We just need at least two, which we do have. So Q is going to match up with N, P matches up with M, and X matches up with X. So by the angle, angle similarity, we have congruent triangles. So double checking over here, again, subtraction. Because 57 does match up, but 48 and 75, well, we just need to make sure this one's not 75 and this one's not 48. So if we subtract, yep, there we go, 75. So we do have at least two angles. So J is going to match up with Q, K and P, and L and M. So by angle, angle, similarity, those triangles are similar. So for this next one, we have basically a triangle within a triangle. So we have parallel lines, so we have them sharing kind of this angle here, and then we have parallel lines, so we have these angles being congruent as well. So we do have angle, angle. We know the triangles are similar. So we're kind of broken down into kind of four parts in a sense that we have this relationship where we have this little segment and then this part of the segment and then kind of opposite of that segment and then that segment there. So kind of the four parts are going to be helping us set up our proportion. So I'm going to go ahead and make this an X. So I'm going to say 10 over X. So I'm going kind of from the big section to the small section, and then I'm going to go over here, big section to small section, so 14 over 7. And then I'm going to cross multiply. So X is equal to 5. So over here on this one, we're going to kind of compare this triangle to this big triangle. So it's kind of a triangle within a triangle. So we're going to kind of compare side to base, or kind of like base over base. So base of the small over base of the large is going to be equal to the side of the small triangle over the side of the large triangle. So base for the small is 6. Move down here. Base of the large is 10. Side of the small, well, here is this, again, triangle that we're looking at. It's 10. Now the side of the large is AD, which is 10 plus X. So we're going to have a 10 plus X down here because it's both 10 plus the X, that whole length there for our large triangle. So now we're going to cross multiply, and 10 times 10 is 100. 6 times 10 plus X, we're going to have to distribute. Plus, and then subtract. So 40 equals 6X, and then divide. And when we divide 40 by 6, x is equal to 6.6 repeating for our answer. So again, I kind of need to determine which direction I'm going for this next one. I'm going to go from the big triangle to the small triangle. So let's go ahead and do base, base. So big over small. And then I need to go big over small. Making sure that I go that same direction for each proportion. And then I'm going to cross multiply. And we've got some distributing that's going to happen here for both. $33x plus 88 is equal to 38.5x plus 77. And then let's go ahead and subtract our 33x. 88 is equal to 5.5x. And divide. So x is equal to 2. And it wants us to find AC. So AC is this one right here. So I'm going to go ahead and plug 2 in. 3 times 2 plus 8, which is 6 plus 8, which is 14 for AC. All right, next we wanted to, Josh wanted to measure the height of the Sears Tower in Chicago. So we used a 12-foot light pole, measured its shadow, and then used the shadow for the building. And so we're going to set up a proportion. Let's go ahead and do the big over small. Kind of help us. So I'm going to go ahead and do height first. So big height is x. Short or small height is 12. And then big shadow is 242. And short or small shadow is 2. So now I can go ahead and cross multiply. 2x is equal to 242. And divide by 2 to get... And that has to be multiplied by 12. So actually, we don't divide by 2 yet. We got to multiply those, which is the 2,904. There we go. 12 times 242. And now we cut it in half to get 1,452 feet, which makes a little more sense anyway for the height of the Sears Tower.